Good morning, everyone. Today we are going to discuss about networks. Network means a group or system of interconnected things or people. So, in networks can be the interconnected things or people, everything. So you know that the biggest world biggest network is www, okay, World Wide Web. So here, if anything is interconnected, we say that it's an example for network. So here I have given examples: network 1, network 2. Here, these are the points: 1, 2, 3, 4. So 4 points are connected each other. So we say that it is an active network. Similarly, in this example, we have how many vertices? 1, 2, 3, 4, 5. Here 5 vertices are interconnected. That is why it is an example for network. Now I have some notes here. Listen, network with arrows are called directed graphs. Here you can see in this network. Here you can see some arrows. Okay, so that's why this network is called directed graph, because there is a direction. That's why this one is an example for directed graph. Directed graph, also called digraph. Then network with no arrows are called bidirectional. So in this network, here A to D, you can see there is no arrow, which means it is bidirectional. Bidirectional means we can move from A to D as well as D to A. But here A to B, in this case you can move only from A to B, but not from B to A. That's why here A to D is bidirectional, which means you can move A to D as well as D to A. D to C as well as D to C means you can move D to C as well as C to D. It's both directional, bidirectional. B to C, C to B. But here B to D is not possible, but you can move D to B. So some are bidirectional, but some are unidirectional. Okay, so here you have to know bidirectional and unidirectional. Okay, so which means network with no arrow is called bidirectional. Then third point is metrics used to describe digraphs are called adjacency metrics, which means this given digraph can be changed into uh, adjacency matrix. Okay, so that matrix, I will give you one example below. Okay, how to describe a adjacency matrix into digraph, as well as how to describe a digraph into adjacency matrix. Then fourth point is, can we replace the two edges going in opposite direction with one edge with no arrow? Sometimes like that there will be movement, like there will be direction A to B as well as B to A. So that is, you can represent by an edge with no arrow. Yes, same thing I have already explained. For example, A to D. A to D is bidirectional. Bidirectional means this one you can replace and draw one A to D with one arrow mark, and D to A another arrow mark. Okay, that also correct. Now let's see how to make an adjacency matrix for given digraph. Listen. Here, create a matrix for the given diagram. Here you can see one digraph. So how can we make one adjacency matrix for the given digraph? So first thing what you have to do is, here how many vertices are there, how many corners are there? A, B, C, D. So we have 4 corners. So 4 corners means when you make an adjacency matrix, we have to write A, B, C, D. A, B, C. Here also A, B, C, D. Because there are 4 edges. If there are 5 edges, then we have to keep A, B, C, D, E. Here also A, B, C, D, E, like that. So first step is note the how many edges are there. So that we have to mention here A, B, C, D, A, B, C, D. Sometimes it can be different alphabets also. Okay. Then second step is here you have to check A to A. Is there any connection from A to A? A to A. Yes, there is a connection, right? You can see here one A to A. This is called loop. It is called loop. So A to A there is a connection. So we will write A to A is a 1. Okay. Yes, A to A there is one loop. That is why one loop means A to A there is a 1. Next one, A to B, second letter A to B. A to B, yes, A to B there is one arrow mark. A to B. A to B there is a 1 connection. So we will write 1. A to B is 1. Now let's see A to C. A to C. So in this diagram, next one A and C. A to C. A to C, A and C. C is here, right? So there is no direct connection. Okay, there is no direct connection. A to C, there is no direct connection. A to C, there is a connection, but that is A, B, C. A to B, A, B and C. But we should not consider that one. When you make adjacency matrix, we have to check whether there is a direct connection is there. So A to C, from A to C, there is no direct connection. That is why A to C 0. Next A to D. Yes, A to D. Yes, there is a connection. No arrow mark means, here you can see no arrow mark. No arrow mark means it is a bidirectional. A to D as well as D to A also possible, right? So that already we have mentioned. Okay, A to D there is a connection. A to D, because no arrow mark means both bidirectional. A to D is possible as well as D to A also. So A to D is 1. Similarly, we can write all the elements in the matrix. Yes, you can see here now B2 from B to A there is no B to A there is no connection, because there is a connection from A to B. There is no connection B to A. That is why B to A is 0. B to B. B to B there is no loop. B to B means there should be a loop. There is no loop. That is why B to B is 0. Then B to C. B to C. Here B to C. B to C there is no connection. Connection is there, but there is no arrow from B to C. B to C there is no arrow. That is why B to C 0. Then B to D. B to D no connection. B to D no connection. That's why 0. Next one is C2. So let's see the vertex C. From C to A. C to A. C to A there is no connection. 0. C to B. C to B, yes, there is one arrow. C to B. That is why C to B 1. Then C to C. Yes, there is C to C. One loop is there. That's why 1. Then C to D. C to D. C to D there is no arrow. C to D there is no arrow means 0. Then D to A. D to A. Yes, here no. You can see one edge without arrow means it is a bidirectional. D to A is possible, right? So D to A is 1. Then you might be thinking A to D also there. A to D already we mentioned. A to D here 1. A to D already we mentioned here 1. Now we are writing here D to A. D to A is 1. Then D to B. D to B, no connection, 0. D to C. D to C, yes, there is a connection, D to C, that is why 1. Then D to D. D to D, there is no loop, that is why it is 0. So this is how to make an adjacency matrix for a given diagraph. Okay, now you try one. Okay, so I'll give you one example for you. Let's try this question. So here C to B, C to B, you can see two arrows. C to B, how many arrows are there? Two arrows, which means when you write many matrix C to B, you have to consider two. C to B, one is here, C to B here, another one. Okay, so C to B is 1, but A to A 1 loop is there, but C to C no loop, right? So you try once. So dear students, if you like my video, please don't forget to subscribe. Thank you.